let's talk about another application of factoring, which is to sketch quadratic functions that are already factored for. So let's say we have f of x is equal to 2x minus 1 times x plus 3. Basically, there's two things that we want to know. We want to know the a value, so we can decide whether it's concave up or concave down. We also want to know the x-intercepts, which is when y is equal to 0. Let's do this one at a time. Okay. So the a value, let's actually expand this out, and you'll see very quickly that the a value is going to be 2. Okay, so when you write this in standard form, you can see a is going to be 2. And that means that it's going to be concave up, like a happy face. Now, for the x-intercepts, or the zeros, you're going to solve when y is equal to 0. So when 2x minus 1 times x plus 3 is equal to 0. You'll notice this is already factored. So we can say either 2x minus 1 is equal to 0 or x plus 3 is equal to 0. That gives us two x-intercepts, 1/2 and -3. So if we want to draw a quick sketch of this quadratic, we can say, okay, this is going to be 1/2, this is going to be -3. It's not terribly to scale, but you get the point. And then it should be a happy face, so it'll look something like this. So there's your quick visualization. Now, if you're in the position where you actually want to know exactly where the vertex is, that's pretty easy now because you know that the axis of symmetry is right in the middle of these two zeros. So let's say axis of symmetry, the h value should be the average of -3 and 1/2. That's going to be -5/4 or -1.25. So that's the x-coordinate of our vertex. And then the y-coordinate, which in this case is our minimum, you're just going to plug in this value -1.25 into the function. So, and you can use that using any of these expressions because they're all the same. Let's say you did 2 times -1.25 minus 1 times -1.25 plus 3, and you evaluate that. You're going to end up with the number -6.125. So now you know exactly where that vertex is, -1.25, -6.125. Okay, let's do one more example. Let's say we have this this function -8x squared plus 22x minus 15, and we want to graph it. And specifically, we also want to know where the x-intercepts are. Again, we can factor this. Now, one thing I'll notice right away is that a is negative. Okay, so it's going to be a sad face. Also, you'll notice that when you factor it, you don't really want a to be negative because it's kind of annoying to think about all the possibilities. So we're going to factor out the negative, like so. So now it's a little bit easier to think about because a is positive and c is also positive. Now when you factor this, you're going to get I think 4 times 2 and 2 times, no, 4 times 5, hang on, this is not coming to me. Okay, so 8 is 1 and 8, 2 and 4. 15 is 1 and 15, 3 and 5. Right, we want this combination of 2 times 5 and 3 times 4. That's going to give us 22. So we want 2x and 4x and 3 and 5 in such a way that the 3 and the 5 are multiplied by the correct things. And then we want a negative 22, so this is our factorization. Okay. So now that we have our factorization, we know that the x-intercepts we need to solve when this thing is equal to 0. So that means 2x minus 3 should be equal to 0, or possibly 4x minus 5 is equal to 0. We're going to get two different x-intercepts here, 3/2 and 5/4. And then the rest of the process is the same. So, okay, this one is 1.5. This one is 1.25. So if you were to graph it somewhat to scale, let's say it looks kind of like this. We also know that it's a sad face parabola, concave down, something like this. Now, again, if you just want like a quick sketch of that with the x-intercepts, that's what you do. If you want the vertex, now that we have the zeros, that we know, again, it's right in the middle, axis symmetry. So we're going to average these two values. We're going to get 1.375 for the h value. And then for the y-coordinate, which is our maximum value, we're going to do f of 1.375 using any expression. When you calculate that, you're going to end up with exactly 1/8 or 0.125. So therefore, our vertex is at 1.375, 0.125.